All right, so now we're going to move on to the cube root. So the number b is a cube root of a if b cubed equals a. Well, and that's because if we go ahead and we take the cube root, well, if it's going to let me write here, if we take the cubed root of b cubed, that's equal to the cubed root of a. Well, those cancel, and so we get b, and that's equal to the cubed root of a. So that's what we have here. B is the cube root of a. Okay. Now, one thing to note on all these radicals. So if we have, say, the cubed root of something, that's the same thing as saying something to the 1/3 power. Or if we have the square root of something, that's something to the 1/2 power. Or maybe we have the fourth root of something. Well, that's just going to be something to the 1/4 power. And so whatever that is going to go under here. Okay. Now, when we have even the 2 or the 4, these have to be positive unless we want imaginary numbers. Now, with the odds, it doesn't matter. We can have plus or minus. So again, these can be plus or minus. These always have to be plus. Okay, so that's kind of a key thing to think about when we're doing the roots. We can have it as a radical over here or as a power of a fraction over here, and they both mean the same thing. And sometimes it's easier when we have something like this. So if we had to rewrite that, if we have b cubed to the 1/3, well, that's multiplying. So 3 over 3, which is equal to 1. So that becomes b to the first. And so that's what this represents. And so when we do it sometimes as this, it's easier to see why that becomes b to the first than when we have something like that. So it all depends on how you view things and how it's going to work. Now we're supposed to evaluate here the cube root. So now we have to think about, cube roots. What are cube roots of these values? So what times what times what is going to give us 64? Well, if we take 4 times 4 times 4, that gives us 64. So 4 to the third, and the cube root of that is going to give us a 4. What about 5? Well, what about negative 125? Well, that's going to be a 5 because 5 times 5 is 25 times 5 is 125. But we have a negative, and so that's going to give us a negative 5 for our answer. Now here, the cube root of 1. Well, that's just going to be 1 because 1 times 1 times 1 is 1. So that will be just 1 for the numerator. Now the denominator, 2 times 2 times 2 is going to give us 8. So the cube root of 2 cubed is going to give us a 2. So that should give us a 1/2. Okay. And so that is how we evaluate those. Again, we have to think about what it is. So that was 4 times 4 times 4. So that's 4 cubed. And that's all to the 1/3 power. Those cancel and we get 4. This was a negative 5 times a negative 5 times a negative 5, which is a negative 5, cubed. And that's all to the 1/3 power. And so that just gives us a negative 5. And this was 1/2 times 1/2 times 1/2, or 1/2. Let's put a cubed here, and then we'll put it to the 1/3, and so that gives us just 1/2. Okay, so that's how we're going to look at these. So our notation, the nth root of a, means we're going to have b to some n power is equal to a, where n is a natural number called the index. Okay, so it could be, 2, 4, 6, 1, 3, 5, whatever. And so if n is odd, we're finding the odd root, and if n is even, we're finding an even root. Now, if a is greater than 0, so, we have a positive number here, and if we have the nth root of a is a positive number, that's going to be what we end up with an answer. Now, if a is less than 0, and if n is odd, so in other words, if we have a negative a under here, then if it's odd, then it's going to be a negative number. And if n is even, so 2, 4, 6, 8, then it's not a real number. Remember, I said it's going to be an imaginary number, and so that's what we have on this case, and it's going to be imaginary. Okay, so that's what we're going to have if it's that. So it's not real, it's imaginary. All right, so we're going to find each root if possible. So we want the fourth root of 256, the fifth root of negative 243, and the fourth root of negative 1296. Well, with that last thing we just did there, a here is less than 0, and it's the n root, so it's this one. This one is not going to be possible. That's not in the case here. It's going to be an imaginary number. Now this one is odd, it's negative. We can still do that one. This is even, and it's positive, so we can do that one. So there's only two of these we actually have to do. So thinking about the fourth root of 256, well, if we have 4 times 4 times 4 times 4, that gives us 256. So the fourth root of that is going to be just 4, because remember, this is 4 to the fourth power, and then we're taking that raised to the 1/4 power, so those cancel, and we just get 4. Now this one's going to be a tricky one if you haven't thought about that one before. That's going to be the 3's, because 3 times 3 times 3 times 3 times 3 is going to be 243, and now that has to be a negative, so it's going to be -3 all to the fifth power. And then if we go ahead and we want to write that in kind of the notation as we've been doing, that's going to be to the 1/5. 5 times 1/5 is 1, so that becomes our -3. Now our last one, again, we already know it's an even root of a negative number is not a real number. It's an imaginary number, so we can't find that root. All right, let's stop there and we'll come back for some more.